Hi team, this video is going to look at the index laws and specifically the first two laws, which are multiplying and dividing powers. If we quickly do a recap of something like x squared, it means the same thing as x times x. In the same sense, x cubed means the same thing as x times x times x. In this particular example, x is the base number. We use index notation to provide an easy way to show the repeated multiplication of the base number, where the index, or the power, so for in this example is 3, represents how many times the base number is multiplied. Alright, so let's take a look at an example. So take 2 to the power of 5 multiplied by 2 to the power of 3, for example. 2 to the power of 5 means the same thing as 2 times 2 times 2 times 2 times 2. Alright, we can multiply that by 2 times 2 times 2, and that is the same thing. If we simplify all of these 2's back together, we would get 2 to the power of 8. So the example on the previous slide was showing the index law 1, which is the multiplication law. So there's an easier way of doing this rather than expanding out every single time, and what it is it uses this rule of a to the power of m times a to the power of n equals a, where the two powers are added together. Okay, a has to be the same base. So for example, if we had two numbers that both have a base of 2, okay, and one has a power of 5 and one has a power of 3, the way that you can simplify it, rather than expanding out all the 2 times 2 times 2, is you can say it's the same as 2 to the power of your two powers added together, 5 plus 3, which is the same as 2 to the power of 8. Alright, so let's take a look at the second index law now, which is when you divide numbers that have indices. Okay, so when trying to divide indices, we'll look at first how you would just normally expand out, and then maybe a simplified index rule that we can use instead. So what we'll have a look at is 5 to the power of 10 first is written here, which is the same as 10 groups of 5 multiplied by 5. Okay, and then the bottom here we now have 5 to the power of 7 expanded out as well. Alright, the step that we would do is we would cancel out our 5's until the point where we can't cancel out anymore. So for example, if we cancel 1 out on top, okay, we'd cancel the 1 on the bottom. So we'll do all the individual groups, okay, until we can't physically cancel out anymore, which leaves us with this remainder of 3 groups of 5 here, which is 5 times 5 times 5, which is also the same as saying 5 to the power of 3. So referring to the previous slide, a simpler way of answering a type of question like this is using this general rule which works for dividing powers. Okay, so what it means is two numbers that have the same base, so for example we have both bases of 5 here. Now instead of adding the powers like the first law, we take the powers from each other, where it's the first power, take the second power. So for example, if we have 5 to the power of 10 divided by 5 to the power of 7, it's the same as saying, well, your base is still 5, but we're going to take our powers 10 take 7, which equals 5 to the power of 3. Alright, so let's try a few examples. What we'll do in this part of the video is I'll write up a few examples and then I'll leave a bit of space on the video, so what you can do is pause the video, try to write the answers yourself, and then press play on the video again and you can double check your answers with my solutions. So, for example, one question would be 3 to the power of 3 multiplied by 3 to the power of 15. So without expanding, you should be able to write your solution here. And our other example can be 8 to the power of 20 divided by 8 to the power of 18. Alright, so try to now answer these questions. Alright, so I'll write up the solutions now. So the way that you'd evaluate the top one, 3 to the power of 3 multiplied by 3 to the power of 15, is the same as saying 3 to the power of 3 plus 15. Okay, which equals 3 to the power of 18. Alright, and with our bottom one, it's the same concept but using our second index law. So we'd have our same base, 8 to the power of 20 minus 18, which equals 8 to the power of 2. All right, so we'll finish up on one slightly more difficult one. So what about if we have something like 5 multiplied by 2 to the power of 7 divided by 2 to the power of 5? Which sort of step do we do first? All right, so lucky for you guys, I'll give you one quick tiny note that I'm sure a lot of you have heard before. All right, and this is an easy way to remember what you should be doing first. All right, so we have BIMDAS, which stands for brackets, indices, multiplication, division, addition, and subtraction. Okay, so you should always, when evaluating any mathematical question, abide by this law. So first off, we'll double check we don't have any brackets. So the next thing that we want to be doing is working with our indices. Okay, so first thing we do with our indices, so we'll just write that core step. So for example, we'd just have an indice which is, 2, that's just a bit, there we go, 2 to the power of 7 divided by 2 to the power of 5, all right, which is the same as 2 to the power of 2, or 7 take 5, which is 2, all right? We can even further evaluate that, because we know 2 to the power of 2 is 4. So then we're just now left with 5 multiplied by 4, which equals 20. All right, so really easy type of question. Don't get confused just when it looks very large with a mixture of just standard numbers or index numbers. Just evaluate it with BIMDAS and you won't have any problems at all. All right, so that's pretty much the end of the video. It's just an explanation of the first 2 index laws. So our multiplication law, which was the AM multiplied by AN equals A to the power of M plus N. All right, and our second law, which was A to the M divided by A to the N, is the same as our same base, A, but this time M take N. All right, so if you just follow those general rules, you shouldn't have really any problems with answering those types of questions. And thanks for watching the video.